Welcome to this video, dear learners. In this video, we're going to be looking at bonding. Okay, we'll be looking at bonding. So please, if you're new to this video, please hit the subscribe button, like and share the video with your friends at school, your families. Okay, so bonding, it is simply a process by which atoms combine. Okay, atoms of different elements combining together. Okay, even though atoms of the same element might also combine together, but most of the time you have different uh, elements combining together. Okay, so for example, you have sodium and you have chlorine. These are different type of elements. Okay, and these are different types of elements. So this is the sodium atom. Okay, with these are 11 protons. Okay, and this is the mass number. Okay, these are 17 protons. Okay, so remember, the number of proton is equal to the number of what? Electron. Okay, it is equal to the number of what? Of electrons. Okay, so now when you look at these two atoms, you are going to notice that we are going to look at the outermost shell. Okay, the outermost shell. So this is the last shell. So this is shell number 1. Okay, shell number 2, shell number 3. Okay, shell number 1, shell number 2, shell number 3. Okay, so the last shell here, so this is called the outermost shell. So the outermost shell is this shell here, this one, the last one. Okay, this is the outermost shell. Okay, similarly again, this is the outermost shell. Okay, so the outermost shell, if you look at for sodium, it is not filled to its maximum. Okay, the outermost shell is incomplete. Okay, incomplete outermost shell. Okay, also here you find that you have got 7. Okay, this is 7 electrons in the outermost shell. This is also incomplete. Okay, incomplete. Okay, so for the outermost shell to be complete, it should either have, okay, it should either have 2 electrons or 8 electrons or 18 electrons or 32 electrons. That's when you consider the outermost shell to be what? To be complete. But in this case, you only have 1 electron in the outermost shell. So this, we say that it is what? Incomplete. Similarly here, okay, you have 7 electrons. They should be what? 2, 8, 18 or 32. But here you have 7. So this as well is incomplete. Okay, it is what? It is incomplete. Okay, so now if the outermost shell has got an incomplete number of electrons, this makes it what? Unstable. Okay, it makes it unstable. It makes it what? Unstable. Okay, and if it is unstable, it becomes very reactive. It becomes very reactive. Okay, it becomes very, very reactive. So these two atoms, they are very, very reactive as you are seeing them here, because they've got an incomplete electron number in the outermost shell. Okay, they have got an incomplete number of electrons in the outermost shell, so they are very unstable and very, very reactive. Okay, so because of this, now atoms try by all means to achieve stability. Okay, they try to achieve what is stability. Okay, so why do atoms form bonds? Why do atoms form bonds? It is to achieve stability. Okay, why atoms form bonds? Okay, number 1, we're saying to achieve stability. Okay, and what do we mean by this? To achieve stability. Okay, So to have a complete number of electrons in the outermost shell. Okay, to have a complete number of electrons. Okay, like I said, the number of electrons in the outermost shell should be either 2, meaning it's complete. If there are 8, it's complete. If there are 18, meaning that it's complete. Okay. Okay. So now, how do these atoms achieve this? Okay. How do they achieve a completely filled outermost shell? Okay. How do they achieve that? So they achieve it by forming bonds. Okay. So how do they form bonds? So number one, they can either lose the electron. They'll either lose electrons to gain electrons. 3, or they can share electrons. So these are the 3 ways. They can either lose electrons, gain electrons, or they will share the electrons. Okay, or they will definitely just share the electrons. So look at this sodium. So this sodium, it needs to have a maximum number of at least 8 electrons in the outermost shell. So it only has 1 electron here. Okay, it only has 1 electron. Now where is it going to get the 7 other electrons to make the outermost shell 8? That's not possible. So the easiest thing here, it's going to lose this electron. Okay, once it loses this electron, this will become the outermost shell, and it's already filled to capacity, which is 8. Okay, so this one will lose 1 electron. This chlorine, it has 7. It can just gain 1 once it gains an electron here. So it will gain 1 electron. Okay, it will gain 1 electron. Okay, it will gain 1 electron. So we have 2 types of bonding based on this. Okay, so these 2 here, losing and gaining electron, they give us what we call ionic bonding, and this one gives us a covalent bonding. Covalent bonding and ionic bonding. Okay, ionic bonding and covalent bonding. Okay, so just briefly here, this is what will definitely take place. Okay, so we're going to show this now. These 2, they can bond together. Okay, sodium can bond with what? With chlorine. How? Okay, how are they going to bond together? How will the sodium bond with the chlorine? So this will lose this electron. Yeah, it will lose this electron, and this electron will be gained by the chlorine. Since this one needs to gain 1 electron, this one needs to lose 1 electron for it to be complete. So let's look at what will happen. Okay, so you have sodium. Okay, so the first shell, it has got 2 electrons, and the second shell, it has got 8 electrons. Okay, so this one, we are not going to write this shell because it's going to lose this electron, so we just end it here. Then we do this. how many electrons has it lost? 1. So we just say it has lost plus 1 electron. It has lost 1 electron. So we write plus whenever it loses, so plus 1. Now this one here, it's going to gain so that they become 8. Okay, so you're going to have chlorine, the first shell. Okay, the first shell, 2 electrons. Okay, the second shell is going to have, second shell, 8 electrons. The last shell, remember the last shell, it had 7. Okay, so 7 electrons. Now it needs to gain the one which was lost from there. Okay, so it comes here. Okay, also you put it in brackets. It has lost 1, so you write minus 1. I mean, it has gained, so whenever it gains, it becomes a minus. Okay, so these two now have bonded. Okay, this one lost 1 electron. Okay, so once they gain, so this one becomes Na plus. Okay, this one becomes Cl negative. Okay, so both of these electrons, both of these atoms have lost 1. This one has lost 1 electron, this one has gained, so they will combine and bond together and become sodium what? Chloride. Okay, they become sodium chloride. Okay, so these electrons have actually bonded. Okay, by what? Losing. And so one sodium lost an electron, but chlorine gained that electron. So if you count the number of electrons in the outermost shell only, so 1 2 3 4 5 6 7 8, it's complete. 1 2 3 4 5 6 7 8, complete. So these electrons, they are now stable, and they've achieved this stability by simply bonding. Okay, by simply what? Bonding. All right, so ionic bonding is a type of bond that occurs between metals, okay, as well, and what? Non-metals. For example, magnesium is a metal, oxygen is a non-metal. Okay, so metals, okay, metals, they lose electrons. Non-metals, they gain electrons. So ionic bonding involves losing or gaining electrons. So gaining electrons is for non-metals, losing electrons is for metals. Okay, for metals. So one atom will gain, which is a metal, and the other will lose the what? The electron. So here what will happen now is this. We're going to draw the atomic structures for the atoms. Okay, so here are the atomic structures. So the magnesium atom, as you can see, it has got 2 electrons. Okay, it has got 2 electrons. So what will happen is that it will lose the 2 electrons. Okay, because the last shell should have 8 electrons. Now this one, it has got 6 electrons, so meaning it must gain how many? 2 electrons. It must gain for this 6 to become 8. Okay, so what happens is this. So this will do what? Will lose 2 electrons. Okay, so you're going to get magnesium. Okay, first shell, it will have this 2. The second shell, 1 2 3 4 5 6 7 8. So now the last share we're not going to draw it because these two electrons that are outside are lost. Okay, so we're just going to do this, okay, and put a 2 plus here, okay, a 2 plus there. So this here, what has happened, this magnesium has lost 2 electrons, so now it becomes magnesium ion, written like this, okay, magnesium ion. So this is an atom. Before it lost electrons, after it loses electrons, it becomes an ion, okay, an ion. So now this oxygen also, it's going to gain 2 electrons, so it's going to gain 2 electrons, okay. We draw it here. So okay, so what is happening here, the first shell has 2 electrons, this one had got 6, but it will gain these 2 electrons that are lost, okay. The 2 electrons that were lost, they will come here, okay. These electrons, where are they coming from? From the magnesium. So this one is written like this, and then this one is now oxygen -2. So the negative shows that it gained 2 electrons from where? From magnesium, okay. So this is what basically happens, okay. So this one had to gain electrons. So now you count 1 2 3 4 5 6 7 8. It is stable and filled to maximum. Also the magnesium, the last share, 1 2 3 4 5 6 7 8, it is also filled to maximum. So what happens, these two ions that have been formed, they will attract each other. Why? Because this is a positive, this is a negative, so they are going to attract each other, okay. They are going to come together, they will come together, okay. So these two atoms, these two ions have, okay. So these, since their charges are opposite, they attract together, then they form magnesium what? Magnesium chloride, okay, magnesium chloride. So these charges just cancel since they are the same, so you get magnesium chloride. So this is how ionic bonding basically take place.